Hello everyone, welcome back to Educquiz. So now we are solving exercise 1 in partial fraction. We go by x squared plus 1 divided by x plus 3 into x plus 1. So we have to represent that in partial fractions. So let's write the question again. Yeah. So to represent this in partial fractions, we have to first check if the numerator's degree is less than the denominator's degree, just like the rules showed. So the numerator's degree here is 2. The denominator's degree is, when you multiply this, you will see that the denominator's degree is going to be 2 because it's x here and x here, which implies the numerator's degree is not less than the denominator's degree. They don't even have to be equal. In this case, they are equal, but this one has to be less. So in this case, for it to be less, what do? You either do long division method or you do the second method, the second shorter method, which was taught earlier. So I'll start with the long division method, which is by default the method that we're going to use. So using the long division method, we are first going to expand this. When we expand this, you divide it by this. So when we expand this, we add x plus 3 into x plus 3. Expanding is going to be equal to x squared plus x times 1, x plus x, 3 times x, 3x plus 3 times 1, 3. Adding like terms together, we are going to have x squared plus 4x plus 3. When we have our answer like this, we can now do the long division. So, having it like this, we know that this expression is equivalent to x squared plus 1 on x squared plus 4x plus 3. So having the expression this way, we can start doing the long division. So having the expression this way, to do the long division method, we do this divided by this. We are going to go by x squared plus 4x plus 3 divided by x squared plus 1, just like that. So if you do the long division method, as we said before, we have to express this in terms of x squared then x, then the last quadratic does not have x. So in this case, it's already in that form. It's already in x squared plus something x plus. You have to express it in the form x squared plus ax squared plus bx plus c. Here it's already in this form. Even here is in this form where we have to see the x. If we want to see the x, we want to see it to make it simpler. If you can solve it without it, that is good and fine. But to make it simpler, you can add x squared plus 0x plus 1. Make it simpler, you can do it like that. So having it like this, I wrote the long division. To do the long division, as we said earlier, we look at the first term here and the first term here. We have x squared here and x squared here. What can I multiply by this x squared to have x squared? So I can say that x squared times 1, they give me x squared. So what do I know? I put the 1 here, 1. And multiplication here, sign. I multiply this 1 by everything here and put under it. So I have 1 times x squared, x squared. 1 times 4x is plus 4x. 1 times 3 is plus 2. When I do like that, put my minus sign here, and I put my equivalent sign. What is the answer? X squared minus x squared is 0. 0 minus 4x is minus 4x. 1 minus 3 is minus 2. So now I see that the power here is already less than the power here. The power of x here is x to the power of 1. The power of x here is x to the power of 2. So I stop dividing. I already have my answer. So from here, what is going to be the answer? The answer is going to be 1, this 1, plus this answer, which is minus 4x minus 2, all on this, which is x squared plus 4x plus 3. That's going to be our answer. So I'm quite sure from now long division method should no more be perfect. So we can see that this answer is the same as this. It is just the same. So this are related to this. So this is related part of fraction. You can leave it like this. This will be part of their answer. This one will be part of their answer. Now you have to make this one to be partial fraction because this one is not simplified to partial fraction yet. It's not simplified. So you have to simplify. Here we can already see that the power here is actually smaller than the power here. So you can start solving. The second step to some partial fraction is you check if the denominator is factorized. That was the second step I was written there. So from the second step, you can see that this is not factorized. You can factorize this. When you factorize this, they are going to have this. So let's put this in partial fractions. Stop. Putting this in partial fraction, what do we have? Minus 4x minus 2 all on x squared plus 4x plus 3. We can see that this is the same like this. I mean the one down, but the denominator here is the same like this denominator. Because it is this denominator that expanded to have this. So we have minus 4x minus 2 divided by this, which is this, x plus 3 x plus 1. Yeah. So that is it. So putting this now, representing this is, we can see that this is type 1. The first type of partial fraction is partial fractions with linear factors at the denominator. You can see that these are linear factors at the denominator. Linear factors because they are square on the end of the x's. So it is a linear, these are two linear factors. So how do we solve this? This is the equivalent to a divided by the first one, which is x plus 3 plus b on second one, which is x plus 1. So from here, well, how do we continue? We write, well, let me copy this back here. So this will imply minus square x minus 2 from x plus 3 x plus 1 is equal to that. Is equal to this. So from here, what do? We find our LCM. What is our LCM? Our LCM is x plus 3 into x plus 1. When we find our LCM like this, it's just a product of this. In this case, that's the LCM. We do this divided by this. We will see that this and this x plus 1 and the x plus 3 is going to cancel. We'll be left with x plus 1. Now, x plus 1 times a will be a into x plus 1. Let's see how we have this. We did this divided by this. X plus 3 into x plus 1 divided by x plus 3. Don't mind the bracket. If you remove the bracket, it is the same thing at any time t. So here you can see that when you cancel this, you'll be left just with the second part, which is x plus 1. Now that x plus 1 upon multiply a, you have a to x plus 1. Yeah. So plus, you do the same, you have b here, b times, in this case, if we did not x plus 1, then it is x plus 3. Just do the same thing. In this case, you will be all of this denominator divided by x plus 1 instead. X plus 1 here. If I cancel this and cancel this, you'll be left with x plus 3. If you multiply b, you have b into x, that will be into x plus 3. And that is what this. This side is not changed, so it is equal to minus 4x minus 2 on x plus 3 into x plus 1. So what do we do next? We cross multiply. When we cross multiply, I'm going to see that this is going to come here, and this is going to come here, and they are going to cancel. If I cancel this from this side and this from this side, see they are the same. They can cancel, and we'll be left just with the numerator parts of both sides. So with the numerator parts at the both sides, you have minus 4x minus 2 is equal to a into x plus 1 plus b into x plus 3. So that's what we are going to have. So from here, we can continue using any of the two methods. The first method is to expand and compare coefficients. The second method is to substitute values. So here, any method can be easy. Any method is easier. So I will choose to substitute values because I'm saying that just by letting this to be minus 1, A will go. Just by letting this to be 3, B will go. Be minus 3, B will go. So I can choose to substitute values. If you choose to expanding this, multiplying this, then equating the coefficient. You bring all about has x together, all about does not have x, you bring on one other side. So you compare, and all about has x be equals to minus 4 because minus 4 here has x. All about does not have x be equals to minus 2. That is if you want to expand. This is what you're going to do. That is what you're going to do. But now, if you choose to substitute values, I'll choose to, the two values I will choose to substitute are, I'll check here, which value will I put here to make this to disappear, Impossible? Yes. Which value is it? I can see that x plus 1 equals to 0, no, x become minus 1. If I choose x as minus 1 plus 1 make all of this disappear. I'll be left just with this. So the first value now I'm going to choose is minus 1. The second value I'm going to choose, what value of x will I put here to make all of this to disappear? So I do the same, I put 3 effect here. When it goes behind, it becomes minus 3. From here, I can see that if I put minus 3 here, minus 3 plus 3 is going to put me 0. It's going to make me have 0 there. So all of this will disappear because 0 times anything is 0. The 0 is inside the bracket. Times v will give me 0. So the second value that I'll put is minus 3. Those are the two let's have two values of x as you solve this. So I'll start with the first one. Let x be equal to minus 1. It implies if I replace minus 1 here, I'm going to have 4. 4 minus 2 is 2. So it's equal to, here, minus 1 plus 1 will make all of this to go to 0. Minus 1 plus 1 is 0. 0 times a is 0. 0 times anything is 0. So all of this will disappear. So I'll put my minus 1 also on x here. Minus 1 plus 3 is 2. So I have 2 times b is 2b. So I have 2 equal to 2b, which implies b will be equal to, you guessed right, 1. Because we divide also by 2. So it will imply b is equal to 1. Okay, answer is square root. So from this you can do your second letter x minus 3. That can be equal to minus 3. And x equals to minus 3. We replace minus 3 in this equation again. We will include minus 3 here. Minus 3 times minus 4 is 12. The minus to cancel is the same like 3 times 4, which is 12. 12 minus 2 is 10. So I have 10 on this side is equal to, when I put minus 3 and minus 3 plus 1 minus 2. So minus 2 times a is minus 2a. And I put minus 3 and minus 3 plus 3 is 0. Minus 3 plus 3 is 0. So 0 times b will still give me 0. So I have just this. Which would imply, if I divide all through by minus 2, I'll have 10 divided by minus 2 will give me minus 5. So I have a equal to minus 5. So I have my answers, my values of A and B. So when I have my values of A and B like that, what do? I just simply rephrase the A. So what I do is I recopy this. I recopy this. But don't forget the 1 that was there. There was a 1 there. So you write 1. You write this. You recopy this. This is equal to 1 plus your answer in partial fraction. This is this. Your answer in partial fraction will be this when you replace A by -5 and B by 1. So your final answer will be 1 plus this or this when you have replaced A. When you have replaced the values of P and B. So what is first this? When you have replaced the value of A and this is equal to. So we are going to write somewhere. I'm going to write it here. I'm going to say -4x minus 2 on x plus 3 into x plus 1 is equal to, what is our A? -5. I can put -5 on x plus 3 plus, what is our B? 1. I can put 1 on x plus 1. That is my answer. To make it more beautiful, you can choose to put this one first. You put 1 on x plus 1 minus 5 on x plus 3. That will make the answer more beautiful. But if you leave it like this, it's not wrong. You're correct. So how the total final answer? The total final answer will be this is equal to 1 plus this, which is -5 on x plus 3 plus 1 on x plus 1. So write your final answer as, you write this, you copy this back, it will be equal to, I'll just put the equal to sign under and write the final answer. So the final answer is 1. And this one comes, let's remember, this one comes from our long division. Coming from our long division, we have this as answer. But we saw that this was not in partial fraction form. This is not the partial fraction. So we can still put this into partial fraction. When it's something like this, then you know it is in partial fraction. You see, because this can be factorized. When it's factorized, you give this, you have an expression divided by an factorized expression. You can still change to partial fraction. So as we saw that this was not in partial fraction, we did this procedure and we found our A and B and put it in partial fraction like this. So our final total answer is going to be 1 plus this thing already in partial fraction, which is 1 plus this. So the total final answer of this, we are going to write the 1 plus this, which we got the more partial fraction. Well, it is -5, so I'll put my -5 minus -5 on x plus 3 plus 1 on x plus 1. And that is how I finalize it. So that is the final answer. So I explained back all of the steps that we used. What did we do first when we saw this? We saw that the power here was the same like the power here, whereas the power on the numerator is supposed to be less than the power on the denominator. So what we did was we did long division and came up with this answer. When we come out with this answer, we see that this is still not a partial fraction. In this person, a partial fraction would have played the answer like that. How do I know that it's not a partial fraction? It is because when I factorize this, I see that I have two factorized expressions. If it was in partial fraction, there would just have been one like this. Right? So from our long division, we see that this was not in partial fractions. Because when I factorize, I see two factors under. So I have to change to partial fraction again. So that is why I will use this procedure, changing it to partial fraction. When I do it, the first step that I do is putting like this, factorizing the denominator. Then when I factorize the denominator, it comes this way. I can put in partial fraction form. When I put this in partial fraction form, I look for my LCN. When I find my LCN, I pause multiply and divide by these values. If when I divide those, then I'm going to have this here. Then you can choose between the two methods. The first method was to expand, compare coefficients, or to select some values. I chose the second method and I found my values of A and D. You could also use the cover method here and find variables if you want. I will see that being correct. Then I have my answer like that. When I found this as my partial fraction, I don't forget this one. I put the 1, then minus this plus this, which was my answer. So that is all for this PG. Thanks for watching and hope you have understood how it was done.